Hello and welcome to our HPCwire video. I'm Tiffany Trader and here with me today is Gilad Shainer, SVP of Networking at Nvidia. Hi Gilad, nice to have you here.
I'm happy to be here.
We've known each other a long time since you've been at Mellanox and now with Nvidia. And there's a lot going on here at ISC here in Hamburg. I thought we could walk through a few of the topics that you're here for and talking about, starting with DPUs, data processing units. Nvidia, Jensen Huang announced last GTC last year that they are now an integral part of the roadmap and the roadmap cadence. So I always think of the DPU as the smart NIC on steroids or the evolution of the smart NIC. How do you view the DPU?
Yeah, so the DPU, it's evolution over time, obviously, right? We had NICs in the past and becoming smart NICs. And now we're talking about data processing unit, which is actually a full data processor on a chip. So BlueField includes the ConnectX IP, or the full networking aspect, with data path accelerator, multiple ARM cores, memory, PCI Express, interface. So it's essentially a full data center on a chip. It's a full computer by itself. And the DPU becomes a critical element as part of building supercomputing platforms. Now, if you look on the three components that we provide or build, it's the GPU, it's the CPU, and then BlueField the DPU. Now, BlueField enable multiple things that didn't exist in the past, which are actually critical in order to support the growing amount of users, the growing amount of applications, and so forth. And if we look on what's happening, essentially, it's AI going everywhere. Right? We see that AI is going everywhere, and therefore every company in the world we need to have access to supercomputing, and we know that building a supercomputer is not that easy. So in order to make supercomputing available for the masses, or enabling supercomputing as a service, we actually need to build a platform that can provide that. And existing platforms are not really set for that, and that's what BlueField comes actually to solve. So with BlueField, or with the DPU, we can migrate the entire infrastructure workload, the entire infrastructure operating system that's today managing or provisioning the servers and doing the security and isolations, all the things that are needed for cloud or for making supercomputing available for the masses. Those things today runs on CPUs, and if you combine it with a supercomputing system, it doesn't really match, because that takes a lot of overhead and takes a lot of toll from the supercomputer, and we don't want to lose performance. We want to keep the bare metal performance. So the DPU comes here, moves the infrastructure workloads, and able to provide the services, the security services, the storage services, all the infrastructure services, maintain bare metal performance, and now we can actually build supercomputers that can provide supercomputing services to more users, more applications, keeping the performance intact and enabling with all the security and isolation that we need.
Okay, great. And I want to get a little bit more into that BlueField roadmap, but before we do that, how does the Nvidia GPU compare to other DPUs that are out there, or there's an IPU out there now? What's the differentiation?
Yeah, of course, as we see that DPUs become a critical part of a data center, supercomputing in enterprise data centers and many other places, then we expect to see a lot of development around that, and obviously we see that. The advantage of BlueField, the advantages of BlueField are actually multiple. First, it's based on ConnectX. And the ConnectX adapter is the adapter that is used in most of the infrastructure out there. So it provides the RDMA, provides all the capabilities, and what made ConnectX so important, it's now part of BlueField. So it has all the advantages of ConnectX inside. Beside of that, BlueField brings things to serve multiple applications. So it's tailored for AI, it's tailored for the data center operating systems, it tailors for storage, and it tailors to enable higher performance for applications. So if you take all of those advantages, it's not just looking on one aspect of things, it's actually providing the broad elements that you need for supercomputing, as well as the ConnectX inside. So that's the great advantages of BlueField.
And you have 4 generations on the roadmap now. When did you launch the first one, and where are you in that series?
Yeah, so there's many more generations on the roadmap, of course. We just putting the few that are coming next. BlueField 1 was created several years ago, and it was mainly targeted for storage, which is today is one of the applications of BlueField, to enable storage platforms or more sophisticated storage platforms, computational storage, and things of that sort. BlueField 2, that came after that, was actually meant to build a data center. And it's something that we use today in order to build the solutions around that, develop the software that is needed, and so forth. BlueField 3, which will come later this year, brings the 400 gigabit per second capabilities, all the elements that we build in the ecosystem with BlueField 2. And we're going to take BlueField 3 into multiple places, taking that in our systems, in our platforms, in the boards that we provide for our partners and customers and so forth. So we'll see a lot of deployments with BlueField 3. And then after BlueField 3, there's going to be BlueField 4 and BlueField 5 and so forth.
And what's the target for BlueField 4, the target timeline?
Typically, we don't talk too much about timelines in the future, but if you look, there is a cadence of around 2 years from generation to generations. If you look on the cadence of GPUs, if you look at the cadence of CPUs and the cadence of DPUs, it's a 2 years cadence. So if we're bringing BlueField 3 later this year, you can see where BlueField 4 is going to be, and BlueField 5 and BlueField 6 and so forth.
Have you announced any systems yet, future systems that will have BlueField 4?
So we announced a lot of platforms that we create and provide to our customers. AGX will have BlueField options, and DGX will have BlueField options, and EGX will have BlueField options, and OVX will have BlueField options.
BlueField,
yeah, exactly. So BlueField enable us to actually enhance the infrastructure services. The infrastructure workloads becomes one of the most complicated workload in the system. And it's not about research, it's about managing the infrastructure. And having that workload running on CPUs or GPUs, that reduces what we can do. So that's why we must have another element that actually run that infrastructure. The second thing is we need to bring security. We need to bring security into supercomputing, and we see how much is needed. And as we move to the future, security will become more and more important. And for doing security in the right way, you must isolate, separate the application domain from the security domain. If you're running both on a CPU, there is no separation. So if a malicious user gets access to the CPU, now it owns the infrastructure. So separating those domains, meaning moving the security domain to run on something else, which is BlueField or the DPU. So we need it for the infrastructure workload, which becomes a complex workload. For security, we're using that in order to improve application performance, because now we can move things or algorithms into the BlueField and work in parallel of what happening on the CPU or GPU. It becomes the critical element, and it will be the de facto network device in every server in the world in the future, in every server. So we understand the value of that, and that's why it's coming on all of our platforms. We already see some systems being built with that. So there is a system in Cambridge University that has DPUs, a platform with GPUs, CPUs, and BlueFields there. We just announced that a system at TAC, at Texas Advanced Computing Center, Lone Star 6, part of that will be upgrade to BlueField in order to provide the TAC user community with access to DPUs so they can start to optimizing their applications and getting all the advantages of the DPUs. We announced collaborations with Los Alamos National Labs around utilizing the DPUs and InfiniBand infrastructure in order to improve their performance or their application performance by 30x in the next few years. There are collaborations with multiple entities in the UK as part of the Iraq, entities in Germany, more entities in the US like Georgia Tech University and so forth. We're looking to have a system in Australia, for example, that will address community there and give them an access. We'll see many more systems with BlueField 2 for actually creating the ecosystems, and then BlueField 3 we'll see a lot of systems coming with it.
It seems like BlueField will be baked into pretty much all the platforms
Correct.
NVIDIA has, yeah.
Correct.
And then one of the things...
Yeah, but it's not just the NVIDIA platform. We're going to see that on other platforms. We're going to see that on x86 platforms. We're going to see that we're going to see DPUs in every server in the future.
Okay.
They will become the de facto NIC. What we call NIC today, DPUs will become the de facto NIC.
And what's the status of that now, of the partnering with other hardware outside Nvidia?
Yeah, so for example, the system in TAC and the system in Cambridge was done together with Dell, just as an example. There are systems that coming with other OEMs, and we're building platforms and solutions with them. So every OEM will have DPU as part of their platforms in the future. Again, that will be an integral part of every supercomputer we will be deployed. Not just, by the way, not just supercomputers, but also enterprise data centers and so forth. And storage systems. Sorry that I jumped.
Yeah, no, that's okay. So one of the things that stood out to me with the isolation that BlueField provides is the importance to biomedical applications and privacy and health data. So you have some customers that are using it for that purpose?
So we are building that infrastructure also for that purpose. Dealing with personal information, for example. And of course, if you have a supercomputing infrastructure, you can do a lot of things on it, right? So you can take personal information, or maybe medical records, or any other sensitive information. And with using the DPU, you can actually protect the data within a supercomputing center, right? So you can bring those applications in, run them in parallel with other applications that share in the same environment, be able to protect, be able to secure the data, be able to encrypt the data as needed, and so forth. So yes, this is one of the applications of BlueField.
Switching gears over to your other passion, InfiniBand. You led the session on InfiniBand here, the InfiniBand roadmap session. Could you give us some of the highlights of that, what you talked about there?
Yeah, we talked about in-network computing, actually, which InfiniBand enables to bring so many capabilities around in-network computing. In-network computing enables to move data algorithms from the host, from the CPU, for example, or GPUs to run it on the network. And the reason to do that is because there is a lot of elements that it's much more effective to run them on the network. The one simple example, we have a technology called Sharp that we have that on InfiniBand. Now, by the way, we also brought it to NVLink, because NVLink, it's a network that connects GPUs, and they also need a reduction on the network there. So we have the same Sharp actually working on NVLink and on InfiniBand. Sharp is a technology that enables to do data reductions on a network. And the data reduction is a critical element in a lot of scientific workloads. It's a key thing for every AI workload. And running data reductions protocols or data reduction algorithms on the host means that you need to send twice the bandwidth on the network. So by moving that element to the network, we're reducing the amount of data that you need to send by 2x. So that means that the 400 gigabit per second network that we have on InfiniBand, it's equal to 800 gigabit per second network. And it gets flat latencies and things of that sort. So there is a lot of element that you want to move to the network because it's going to be much more efficient there. So we have done that part, and we're moving more of MPI elements and more for nickel elements, and actually run them on the network much closer to the data and becoming much more effective. Now, InfiniBand as being a very simple, pure software-defined network, it's not complicate anything from that perspective, and because of that, we can actually bring in-network computing elements into InfiniBand in a very easy way. It's much harder to do it on any other network. So we talked about that, and in-network computing becomes a critical thing on the network side. Beside of that, InfiniBand is now moving to the 400 gigabit per second generation. Full RDMA. InfiniBand is the only network out there, if you think about that it's a full transport offload, which means all the network functions are done on the network. There is no overhead on CPUs. You don't take any of the CPU capabilities instead of running applications. So it's a full transport offload and have hardware-based RDMA capabilities. So moving data directly to CPU memory, GPU memory, from the storage to GPU memory. So that's a great advantages of InfiniBand. So now it's the 400 gigabit per second generation with PCI Gen 5, largest switch radix, so you can build larger infrastructures with actually less network components, saving space, saving power, and so forth. So we're excited with that part, excited with the new in-network computing capabilities that we're bringing. excited to have BlueField 3 as part of that NDR InfiniBand, quantum InfiniBand platform. And we start seeing systems deploy with that. So we're seeing several systems already being deployed around scientific research areas. We're going to see systems in the large cloud environment coming up soon. There are already several systems deployed, but there are things that we cannot discuss. And second part of the year, next year, believe that most of InfiniBand systems is going to be with NDR.
With NDR, yeah. So you have 400 gigabits NDR, and is it 800 gigabits the next step, or next one? Okay.
Yeah. The next one.
Do you have a call letters picked out for that one?
Yeah, it's XDR. Okay. So it's going to be from our perspective, NVIDIA perspective, it's going to be the NVIDIA Quantum 3 InfiniBand platform.
All right.
So Quantum platform is the 200 gigabit per second, Quantum 2 is the 400, Quantum 3 is the 800 gigabit per second, and it's the same cadence as of the DPUs. So every 2 years, you should expect to see a new generation on the InfiniBand side of things.
So where would that put us if you're looking at NDR as being 2021, 2022? And then 2024?
So NDR, it's now in full production.
Yeah.
So we sampled that end of last year,
Yeah.
and now it's full production. So
Yeah. Do the math.
you can take that and get some feeling about XDR.
Since Nvidia bought Mellanox, I think there's been some conversations in the community about Nvidia's commitment to keeping InfiniBand as a neutral platform. Can you speak to that?
Yeah. On the networking side, by the way, Nvidia, if you look on Nvidia or Nvidia options offering or technologies, Nvidia built GPUs, CPUs, and DPUs and the network, and the InfiniBand network, for example, also the Ethernet network with the Spectrum switches. And our customers can choose whatever they want. They can pick the GPUs and another component, or DPUs and those kind of switches and so forth. So people can freely choose, obviously, what makes sense for their infrastructure, what they need for their applications and so forth. On InfiniBand, we're working with everyone. We're working with all the x86 vendors, obviously, with Intel and AMDs and others that build computing infrastructure, all the OEMs and so forth. And happy to have everyone use our InfiniBand network in every data center that they build.
We've covered a lot here. What else is ahead for NVIDIA and networking?
Well, there's a lot of new technologies that we plan to bring in future elements. I think the great part of being within NVIDIA is that we actually design the entire full stack system in that sense, looking from the application, all the software elements, and then bringing the components that are needed, GPUs, CPUs, and DPUs. It's not just looking on one component, one area. It's actually looking on the entire system that is needed to advance research, to advance AI, to be able to solve problems that people didn't solve before. And then when you're coming with this mindset, it changes what you can do and gives you much more flexibility. So you can decide if a new capability needs to come in this area of the system, in that area of the system. You have the options to put it in the right place. So there is a lot of applications that we want to continue and enhance, a lot of applications that we want to enable, a lot of technologies that we want to bring into the data center that will obviously increase the data center capabilities in the future. There is a big infrastructures that will be part of large systems out there. If those are the cloud infrastructures, the AI infrastructures, supercomputing infrastructures, we want to make sure that they're getting the right performance, but we minimize power consumptions. We're adding liquid cooling capabilities. We're looking in integrated optics in the future. There's a lot of very cool technologies. So it's really exciting. Really exciting, and obviously being part of working HPC world or supercomputing world, every day is exciting because every time there's a new technology coming out. I think also that the DPU is something that's going to change the data center, completely change the data center. It will enable us to do things that we cannot do. If you look on data center revolutions over time, cloud enable computing services for everyone, right? So in the past, if you needed to do something, you need to build your own data center. And with clouds, it changed. So now you don't need to build your own. You need cloud. You need compute. You can get compute as a service. Supercomputing is the next thing, and making supercomputing a service that will enable everyone access to supercomputing, everyone access to the ability, or everyone will have access to be able to design AI algorithms, to test AI algorithms. That's important, and the DPU will enable that. So that's it's great to be part of another transition, another technology transition that will change the way that we do supercomputing or consume supercomputing. So there's a lot of things coming in the future, and very happy to be part of that.
Great. So we're here at ISC. Is it good to be back? Good to be back at ISC after a 3-year hiatus?
Yeah, it's good to be back. Good to see people again, meet folks, not just on the other side of the screen. I hope that we'll have more conferences coming, and
we should,
and coming back here obviously next year.
Sure, and SC in November in
SC
Dallas.
November in Dallas.
Yep. Well, thanks for joining me, Gilad. It's nice to see you again. And thanks to you all for joining us at ISC in Hamburg.